Hello and happy Friday. It's Friday, yabba dabba doo. Happy Friday to you. Stay strong. The weekend is coming. And do the Happy Friday dance. Our agenda for today is going to be to review slope, rise over run. Then we're going to do problem number 4, which starts on page 140. Then we're going to do talk the talk on page 143. Anything that we don't get to in class, so if you all don't finish the video, then you'll have to go home and watch it over the weekend. Please don't forget the substitute student expectations that we talked about yesterday. Be respectful, responsible, and safe. I hope that you brought your book. Sit in your assigned seats. The Ways of the Wolf. If you did not bring your book, you need to write it down on notebook paper and put it in your book. And then I'll check books on Monday to make sure that you completed all the problems for your points. All right, so let's start with our first task, reviewing slope, rise over run.
Rise up, right now. We mapping graphs through the triple R sound. Talking points, slope, axes, and origins. Why intersect the problems we solve for them. Rise up, right now. We mapping graphs through the triple R sound. We talking points, slope, axes, and origins. Why intersect the problems we solve for them. The 4 quads start from the top and right, counterclockwise from the positive X to Y. You go around, hit the 2 and then 3, bottom left, negative. Remember that, please. You got a single point on the X, Y grid. There's a single pair of values telling you where it is. The X coordinate goes from side to side. The Y follows the comma to define the point. A straight line between 2 points is a relation. You can represent it with a linear equation. Y equals M times X plus B. If you want to know the variables, listen to me. M is the slope, that's rise over run. It tells you how steep the line is going to become. B is the intercept that's to assess the point at which the line goes through the y-axis. Rise up, right now.
All right, so please get out a piece of paper or grab a piece of paper from the student station and a pencil, and you need to take notes along with the video and write down the problem and work through it. On Monday, not only will I check your book, pages 140 to 140. Okay, so paper and pencil, and you're writing this down, and I will check your book work and your notes on Monday. All right, let's get started with the video. Pause it if you're not ready yet, and then as soon as everybody has a piece of paper and a pencil,
Find the
press play.
slope of the line in the graph. And just as a bit of a review, slope is just telling us how steep a line is. And the best way to view it, slope is equal to
You're writing this down.
change in y over change in x over change in x. And for a constant, this will for a line, this will always be constant. And sometimes you might see it written like this. You might see this triangle, that's a capital delta, that means change in y over change in x. That's just a fancy way of saying change in y over change in x. So let's see what this change in y is for any change in x. So let's start at some point that seems pretty reasonable to read from this table right here, from this graph. So let's see, we're starting here, and let me do it in a more vibrant color. So let's say we start at that point right there, and we want to go to another point that's pretty straightforward to read. So we can move to that point right there. We can literally pick any 2 points on this line. I'm just picking ones that are at nice integer coordinates, so it's easy to read. So what is the...
Okay, so make sure we have written down what slope is, and then now let's take some time and sketch the graph of the line. So at -3, negative 3. So if you want to draw your 0, 0, you could draw it right here, and then you can add. So we're using the quadrant 3 as well. All right, so make sure you plot negative 3, and then 0, negative 1, and then sketch a line through it. Press play when we're ready to move on.
Change in y, and what is the change in x? So first let's look at the change in x. So if we go from there to there, what is the change in x? My change in x is equal to what? Well, I could just count it out. I went.
Which he's doing the run first, but up here he's put it on the bottom. So I think he's just going to show you both pieces, but we will put it as the x part on the bottom.
1 step, 2 steps, 3 steps. My change in x is 3. And you can even see it from the x values. If I go from negative 3 to 0, I went up by 3. So my change in x is 3. So let me write this. Change in x, delta x is equal to 3. And what's my change in y? Well, my change in y, I'm going from negative 3 up to negative 1. Or you could just say, 1, 2. So my change in y is equal to positive 2. So let me write that down. Change in y is equal to 2. So what is my change in y for a change in x? Well, when my change in x was 3, my change in y is 2. So this is my slope. And one thing I want to do, I want to show you that I could have really picked any any 2 points here. Let's say I didn't pick, let me clear this out. Let's say I didn't pick those 2 points. Let me pick some other points, and I'll even go in a different direction. And I want to show you that you're going to get the same answer. Let's say I view this as my starting point, and I want to go all the way over there. So what is my, well, let's think about the change in y first. So the change in y, I am going down by how many? How many units? 1, 2, 3, 4 units. So my change in y in this example is negative 4. I went from 1 to negative 3. That's negative 4. That's my change in y. Change in y is equal to negative 4. Now what is my change in x? Well, I'm going from this point, or from this x value, all the way, let me do that in a different color, all the way back like this. So I'm going to the left, so it's going to be a negative change in x. And I went 1, 2, 3, 4, 5, 6 units back. So my change in x is equal to negative 6. Change in x is equal to negative 6. And you can even see I started at an x is equal to 3, and I went all the way to x is equal to a negative 3. That's a change of negative 6. I went 6 to the left, or a change of negative 6. So what is my change in y over change in x? My change in y over change in x is equal to negative 4 over negative 6. The negatives cancel out, and what's 4 over 6? Well, that's just 2 over 3. So it's the same value, you just have to be consistent. If this is my start point, I went down 4, and then I went back 6. Negative 4 over negative 6. If I view this as my starting point, I could say that I went up 4, so it'd be a change in y would be 4, and then my change in x would be 6. And either way, once again, change in y over change in x is going to be 4 over 6, 2/3. So no matter which point you choose, as long as you kind of think about it in a consistent way, you're going to get the same value for slope.
All right, so now that we have reviewed a little bit, let's turn to page 140 and start problem number 4. Pause and press play when everyone has their books out. Now turn to page 4. If you do not have your book, then you got to do it on notebook paper. Thank you. All right, so determine the rate of change from each graph. So we're going to do some different graphs here. This graph looks like it's talking about cost in dollars, the Y, and number of pieces of fruit. And then we have the same thing, except it's a different graph. It starts at a 10 on this one and a 20 on this one. C. The two graphs look exactly alike. How could you show different rates of change? So let's go back up here to number 1. It says determine the rate of change from each graph. So we're either going to use this 20 and the 28 or the 28 and the 36 with its x to find it. So let's try using this one, 60, 28, and this one, 120, 36. All right, so our rate of change, or our slope, our rise over our run, to get from here to here, I go up 28 to 36. So that would be 2, 4, 6, $8 over pieces of fruit. So write your pieces of fruit. How many? So I'm going from 60 to 120. So that would be over, oh, too much, over 60. So $8 over 60. Whoa! Okay, and then let's look at B. So this one, come on. How do I scroll? Okay, here we are. So let's use 0, 10, and 6, 14. So to get up there, 2, 4, and then run. How many do I have to run out? So 0 to 6, that would be 6. So rise over run is 4 to 6. And then let's look at A again. A was 8 to 60. So are those different or not? And the two graphs look alike. How can they show different rates of change? So the line looks similar, but how does that work out? So go ahead and write a statement for that and press play when you're ready. Do C. Go. There are lots of possible answers we could have said for C. The rates of change are different because the scales are different. So in B, we counted up to 20. On A, we counted up to 40. So this one shrunk. So the problems are different problems. And once here again, we got 8 over 60 or $2 for 15 pieces and $2 for 3 pieces. So it is different. All right, next question. Number 2. Determine the rate of change from each graph. All right, so we have A and B. So go ahead and at your table, find the rise or the fall. So this one's going to be negative something over the run. Rise down or fall down and run over. So figure out that over the run, and it's going to be pounds, because that's on the Y, over weeks. And then on B, it's going to be pounds over weeks again, and find your rise or your fall, so negative something, over your run. Press play. Once you have tried that, you may work with a neighbor. Go. All right, let's check A and B, and then you're going to have to do a statement for C if you haven't already. The rate of change is negative 3 for 2. So every time I go down 3, right, I go over 2. So if and I bet we got that by simplifying. So 24 Oh, yeah. Here we go, because they're counting by 2. So down 3 over 2 is right here, and see, that's the 2. And then if I went down 6, I should go over 4, which I did. So it simplifies to negative 3 over 2. You might have had negative 6 over 4, or negative 12 over 8, but that would simplify down to this. On this one, is it the same? And it is, but the graphs look different. So why might the graphs look different, but it has the same rate? So if we look here, this went to 30, this went to 10, and it was stretched out. This one went to 60, and this one went to 10. So this is the same graph if I cut this off here. So it's kind of tighter. So on C, how could they show the same rate? Write a statement for that and compare and share. Go. The rates of change are the same, but the scales are different. All right, let's do the next page. Number 3, determine the unit rate of change for each graph. So for each graph, you're going to find the slope, the rise or the fall, the rise up or the rise down, and if you're going down, then it's negative, over the run. And try to use perfect points. That'll make it easier. Our crew member here says, that's a happy face, sorry. Any ratio with a denominator of 0 is undefined. Any value over 0 is undefined. So I bet one of these will have a rise up, but our run is going to be nothing. And if that happens, then we should call that one undefined. So I'm going to go ahead and do A with you, and then I want you to do B, C, and D, E, and F, and G, all at your seat. So I'll do A, and then you can do the rest of this page, and then we'll check it at the end. So A, I have a point right here, 1, 4, and then I have a point right here. So my rise up would be 1, 2, 3, 4, and my run would be, we're counting by ones, 1, 2, 4 over 2, or 2 over 1 if I wanted a unit rate, but it doesn't say. Oh, it does. It does say that. Sweet. Okay, do the unit rate. So find it and then simplify, which means it has to go over 1. So now work on B, C, D, E, F, G. Don't forget what Our Lady said. If you end up with 4 over 0 or 7 over 0, that means that the graph's undefined and you can't determine the unit rate. Do this, take about 5 to 10 minutes, maybe 7, and then we'll check our work. This is a reminder that we should be on task, because if we're not on task and you do not finish this video in class, you do need to go home, log on to Blackboard, and finish it for homework over the weekend. So I appreciate staying focused and working through the book with me even though I'm not here. All right, 3A we did together. 3B, -1 mile per 1 hour. C, 0 miles per hour. So that one's fine because you can go 0 miles in an hour. But D, you can't go, if you're doing 0 hours, if there's no time, then you can't go miles. So for D, that's why it's undefined. E, how can you tell from the graph whether the rate of change will be positive or negative? So if we look up to these two up here, if the graph is growing, like I'm climbing a mountain, then it's positive. If it is going down, like with the skier, then it's negative because I'm getting closer to 0, or I could even go negative. So this one, positive, because it's a rise up. This one, I start here, but there's no opportunity to rise up. I fall down, so you know it's going to be negative. So write statement. You should already have it. For E, the book says, if the graph is increasing when reading it from left to right, the rise over run will be positive. If the graph is decreasing when reading it from left to right, the rise over run will be a negative value. F, describe the graph's direction if the rate of change is equal to 0. So if the rate of change is equal to 0, then it's horizontal. Remember, we've been practicing horizontal, vertical, horizontal, vertical. All right, and then G, if it's undefined, then it's a vertical line. So 0, undefined. Rate of change is 0, horizontal, undefined, vertical. All right, good job. So far we have gotten through problem number 4, and now all we have left is the talk the talk. Calculate the unit rate for each car. Show your work. So to me, there is an A car, a B car, a C car, and a D car. So this overlaps here, but that's okay. We can use the points. So for like C, I could use this point because it's on that line, and another perfect point for C is there. For D, I could use this point, and they gave me this perfect point. So in your book, I would go ahead and like label your points or figure out, and I want to do A with you. So for A, first let's find the slope, and then we can change it to a unit rate. So you got to find them all, but I'll do A with you. So for A, this is a perfect point, and 0, 0 is a perfect point. So my rise would be up 60. And then how many over? Over 1. 60 over 1. Well, that was silly because it's already a unit rate. But to get it correct, when I check them on Monday, you need to put your units. So that's 60 miles. So write miles over 1 hour. So I'll do one more with you since that one we didn't have to simplify. Let's do C. So if C, I did these 2 points. This one is 20. So if I go up this many, 5, 10, 15, 20. So I would go up 20 and I would go over 1, 2, oh Billy, sorry, up 20 and then over 2. So that would be a 20 over 2. This is for C. So you'll do B and D. And then if I want that as a unit rate, what goes into both 20 and 2? Well, I have to make the 2 a 1. 2 divided by 2 is 1. 20 divided by 2 is 10. Make sure you write miles per hour. All right, you have to do B and D. You can do that at your desk. Okay, 2. Describe how the steepness of the line is related to the rate of change. So just looking at A and B, this was 60 over 1, and B was 10 over 1. And you can see that A is steeper. So when the line is steeper, is the unit rate, is the numerator larger or smaller? Come up with a statement, and I'm going to check number 2 as well on Monday. All right, so let's check here. We got through both of these. Underneath the flag is our objective for the day, find slope using graphs. And our homework, and the homework says these 2 things. So if we got this far, then you don't have homework tonight. So happy Friday, and I hope you got through the video. If there's extra time, maybe we can play silent ball if everyone's finished. But we cannot break any more bookshelves. And we need to be responsible, safe, and respectful. And have a good weekend, and I will see you on Monday. Please bring your books on Monday because I need to check your work. Have a good night.